Thank you, Vicky. Hello, everybody. Good morning, good afternoon, good night, wherever you are. Um, this is the fifth session on the Kia DHCP server, and today we will talk about monitoring, logging, and Stork. So what is Stork? Now, this is the login of the Stork web interface. And Stork is a dashboard, a graphical web-based dashboard for the Kia DHCP server. It is being used to monitor all the Kia services. So you can monitor the DHCP components, the dynamic DNS component, the Kia control agent, and also the high availability states. And in the Stork interface, you will see failures, fault conditions, and other unwanted events. And you can also use that to create alerting mechanisms. It is currently under active development, and there are monthly releases from ISC, so it's changing rapidly. It's already quite usable and useful. However, it's not feature complete. So there are still a lot of stuff that will be added in the coming weeks and months. And there are still some rough edges because it's under active development, it's not finished. So experience that not everything is completely polished and easy to use. However, if you have some ideas or suggestions how to make Stork better, please let us know. You can run Stork on these operating systems on Ubuntu Linux, Fedora Linux, Red Hat, and CentOS, and macOS. Although macOS is not one of the official supported operating systems, it is what a lot of the ISC developers use as their working machines. So naturally, they test Kia and Stork also on macOS. It might work on other Unix-ish platforms, just that it has not been tested so far. You can run Stork co-located on the same machine as a Kia service, or you can even run everything on one machine. So you can have the database, Stork, the Kia DHCP, and the Kia control agent, and everything on one machine, or you can spread that out and have everything on different machines. So here we see a picture of the architecture of Stork, and Stork is in the middle, and Stork is composed out of two main components. One thing is the Stork agent, and the Stork agent talks to the Kia modules, the Kia DHCP servers, also the dynamic DNS and the control agent, and it fetches the information from these machines. And then there is the Stork the Stork server, and the Stork server gets all this information from the Stork agent and stores that into a PostgreSQL database. And then Stork server also provides the web interface, so it can pull the data from the PostgreSQL database and show that in a graphical, nice web interface where you can see the current state of the Stork of the Kia services. You also see on the lower left side that we have ISC bind there. That is something that is already there, but there's not much functionality in terms of managing the bind server, but that might be expanded in later versions. So for this webinar, we focus only on the Kia part. Usually, the administrator will log in to the Stork server with a web browser, log in there, and then get a status overview of all the Kia services, whether they are up and running, about the pool utilization, and other interesting facts about the Kia installation. However, there's an optional part which is called Prometheus and Grafana, and these are popular monitoring solutions that are already used in other situations, and they can also make use of the data that is the Stork agent is delivering. So Prometheus and Grafana are not parts of the of Stork. They are independent open source products, but you can combine them with Stork and use them to have a much richer graphical user interface monitoring-wise. So what do you need to run Stork? The Kia control agent needs to be configured in running and needs to be configured in the way that the control agent can talk to the other Kia components. And we need a PostgreSQL database, and that must be version 11 of the PostgreSQL database or a later version. And I highly recommend at the moment, if you want to use Stork, to install Stork from the packages. Packages are provided for Red Hat, Centos, and Fedora, and Debian and Ubuntu Linux systems. And you can find the packages in the ISC repositories on cloudsmith.io. It is possible to download the source code and compile that yourself, but at the moment that is quite a complex process that is somewhat made easier by a very intelligent build script that is there, but that works with Linux containers and pulls all kinds of other dependencies on there. So if you compile from source, you should do that on a dedicated build machine and not on any production DHCP server, because it will just clutter your system with stuff that you might not want to have on a DHCP server. But doing installation from the packages is the easiest path from now. So here, this is the steps you will do on a CentOS 8 system to install Stork. First, you download and enable the cloudsmith.io repository for the Stork packages. And after downloading the repository data, you should always have a brief look into the repo description, see if everything is sane there, and if it looks good, enable the repository with DNF config manager. Then a DNF make cache will download the latest packet lists from the repository, and it will also ask for the confirmation of the cryptographic key that is being used to sign the packages. And then we can install the Stork components. The agent is the ISC Stork agent, and then there's ISC Stork server. You can install both on the same machine, or you can even split them up onto separate machines, or you can have the agent running on the same machine where the Kia control agent is running, and then Stork server on some other machine. As mentioned, Stork requires a PostgreSQL database, and it requires the version 11. If you install on Red Hat /CentOS 8, this operating system provides different versions of the PostgreSQL database via its upstream repositories. So be sure that you select version 12, because version 10 is the default, and there's, to my knowledge, no version 11 in the repositories. So 12 is the best choice for running Stork. But you have to change that with the DNF module enable command to get version 12 and not the default of which is version 10. So if you do DNF module list PostgreSQL, you should see an output very similar to this, that the PostgreSQL version 12 is the enabled one and 10 is being the default one. And if that is correctly configured, we then can install PostgreSQL Server and PostgreSQL Contrib, which contains additional PostgreSQL modules that are being used in Stork. Before we can start PostgreSQL the first time, the database needs to be initialized on a Centos system that is being done with PostgreSQL -setup --init db, and then we can enable and start the PostgreSQL database system with systemctl enable --now PostgreSQL. On a Debian Ubuntu system, this will be done automatically as part of the installation process. And once you have installed PostgreSQL, the database will be up and running on your system. It is recommended to have a dedicated database and dedicated user for Stork. And these are the steps for creating these. We change into the Postgres user context and then start the PostgreSQL client, create a user named Stork, or it can be any other name, just it should be a dedicated user with some secure password. Then we create the database for Stork and apply all the privileges to the user Stork to the database. And then in an additional step, we change into the Stork database and create an extension, the PostgreSQL crypto extension, which is required for this database for Stork to run. And then we can quit the PostgreSQL client. Unlike the other Kia components, which are configured with its own configuration files, the Stork agent and also the Stork server is configured via environment variables. And these environment variables live in etc Stork, agent.env, and server.env. And they will be read by the init system or by systemd. This is what we see here is the configuration for the agent. And we configure the agent's address and port. And these are the address and port where the Stork agent will be listening with the Stork agent's own REST interface. So the Stork server will talk to this port and to this IP address. And then on the lower part, we have the configuration for the Prometheus exporter, which is optional and only required if you want to run Prometheus. Then you can configure there either the same IP address or a different one. If you have the same IP address, it should be a different port. And then the exporter interval in seconds, that is the interval that the Kia Stork agent will deliver the data to Prometheus. Once we have configured the agent, we can start the agent and make sure that the agent is running. The agent is written in the Go language. It's a static binary. So once you have the binary there, it usually doesn't have any dependency problems in the system. It just works and runs. So it's quite nice and easy. Configuring the Stork server is quite similar. Again, via environment variables. What we configure here on the server side is the database connectivity. We configure the host's IP address of the database, the name of the database, the username that we have configured for the database, and the secure password that we have given. Also, the Stork server can be controlled via a RESTful API. And if we want to use that, we have to configure the host and port. And if we want to make that secure with the transport layer security protocol, then we have to specify the private key certificate and the certification authority certificate, that is the root of that certificate chain. And optionally, we can define where Stork will find its static files that are being used in the web interface, like all the images that are there and other assets of the web interface. And if that is configured, we can start the Stork server and make sure that the server is running. Same as with the agent, the Stork server is written in Go. It's a static linked binary, easy to use, shouldn't make any problems. So I mentioned that Prometheus is a popular monitoring framework, also written in Go. was originally developed at SoundCloud and is currently being further developed inside the Cloud Native Computing Foundation. And it's quite popular nowadays for all kinds of monitoring tasks. And that is because you can find a lot of pre-developed so-called exporters that can feed data into Prometheus. And Stork is no different here. The Stork agent can act as an exporter to Prometheus and can deliver its data there. But the use of Prometheus for Stork is completely optional. You don't need to install and run Prometheus. Just if you already have that, it makes sense to link the Stork agent into the running Prometheus system. And then if data is in Prometheus, Grafana is a visualization web framework, web application that allows the user to create nice looking dashboards. While the dashboard that the Stork server is providing is currently quite static. It's good, but you can't change much yourself in the web interface. It's completely different with Grafana. You can there, with the web interface, you can just by dragging and clicking and moving and adding new visual content there, you can create your own nice looking dashboards with the data, with the monitoring data that you care about. But as with Prometheus, the use of Grafana for Stork is completely optional. You can run Stork without Grafana, and that just works fine. This is how Grafana looks like when it is configured with Kia. And here we see some graphs like the utilization of some pools and the amount of specific DHCP messages being seen by the Kia server. So this is what Stork is and what it can do. And now I will take you on a tour of the Stork web interface. And I've recorded a few small videos to show that. And in the first video, we will see how to first log in into Stork and then create a user. The initial default username and password is admin and with password admin, and that is the super user account in the system. And what you should do as a first step is create a new user and also change the default password on the super user in the system. Here for the user, we put in the email address that is for in later versions of Stork to be able to send email notifications from the Stork system. We define in which group this user is and define a secure password. And now we have a new user account created. Once we have a user account, we can add our running Kia services to Stork. We go to Services Machines and click on Add New Machines. And then we put in the IP address, a host name, and the port number of the Kia agent. And the Kia agent usually runs on port 8080. And here we see one machine being added to the system. And this machine runs Kia 118, and it has DHCP v6 and DHCP v4 configured. Now, here I'm adding a new machine, a different agent, and this is a Kia instance with a lot, with I think 6,000 or more subnet definitions and pools and a lot of data in there. So it takes a little bit more time for Stork to make the first contact and to just load all the data that is provided by this system into its database. However, once the data is being imported and it's in the database, the interface is quite snappy and fast. And we see also this machine has DHCP v4 and it has the control agent running. Here we see in the machines overview, we see both machines. And now we can work with these machines. For example, we can have a look on all the subnets that are defined on the two Kia DHCP servers. And here we see the list of all the subnets, the number of addresses, the number of signed addresses. Currently, that machine was completely idle. There was no addresses, and we see later some addresses in there. If we click on any of the machines, we get an overview of that service, how it is running, and also we can, for example, look at the host reservations. We can have a look at the subnets again. Currently, it's not possible to view the leases, but that is planned for some of the next versions of Stork, so that you can go on the system, go into Stork and get a list of all the leases that are currently allocated. Now here I'm adding a third machine, which is a high availability cluster. And this is the one node of the cluster. And I'm adding the second node of the cluster, and that will allow us to see how high availability status information is being shown in the Kia system. So now this is being added to the system. And here we see down in the on the dashboard page, which is the first page of Stork, that the first machine of the high availability cluster is currently down. If I go with the mouse over the red axis, it will give me additional information. I also see on the right side in the events that the DHCP v4 service is unreachable on that machine. Now it just became reachable again, and we see that in the events part. And now the high availability protocol between the two nodes will start syncing the lease databases. And once the lease databases are completely synced and every service part is being running in its normal state, then the Kia Stork dashboard will also reflect that. That can take a little time, depending on the size of the lease database, the number of subnets and pools that are defined on the machines. But usually it should not take longer than a minute. So now we should have the data here. And yes, we see that everything is green again. The high availability cluster is now up and running perfectly. And here in the last video, we have already some data now in our system. We see in the dashboard that the most popular subnets are being listed there, most popular being the subnets that have the most utilization. We can go into the list of all the subnets. Here it is sorted by subnet ID. And we can also go into the shared networks. And here we see that some parts of the shared networks are already completely utilized, which is not a problem for a shared network because we still have parts of the shared networks which are free. Coming back, I'm now seeing here that some subnets have a problem because they are already two subnets are already 100% utilized. So something is going on in my system, and I see red warning signs and alerts coming up because my subnet is completely run full. When I click on one of the high availability cluster nodes, I not only see that one cluster, I see also the remote partner machine. So here I see on the left side the local server, and on the right side I see the remote machine. And currently everything is good, everything looks fine. And when something happens to one machine, then the status will reflect that, and it will go red. It just happened to the one machine, and we see here that the right one, the remote server, went red. It's not reachable anymore. And the left one, the local server, went into the partner down state. And I can hover over the question marks to get additional information. So that was a quick tour on the web interface, how it looks like and how it works. So you can work with Stork over the web interface, but also you can script Stork with a REST API. So as the other parts of Kia, Stork has an extensive REST JSON API where you can automate the addition and deletion on machines. You can manage users through the API. You can fetch log files. You can fetch the events and create your own notifications, your own monitorings if you like to. You get the information about the reservations and the DHCP statistics on the subnets, like the utilization of the subnets and subnet pools. The REST API is documented from the help menu that you see in the blue help bar on the web interface. The leftmost menu button there is help. If you click on that, you have two different documentations for the Stork API. One from Swagger looks like this, and there's another one that has the same information but in a little different format, which looks like this here. So that was Stork, but there are other monitoring options. Mike Miller has created two shell scripts that list the DHCP v4 and DHCP v6 leases locally from a memfile database. So these scripts directly read the memfile database file and go through that and create a list of the current leases in the file. And these scripts are public domain. You can download them from Mike's homepage that is listed here. And because I'm not using the memfile database myself, I'm using PostgreSQL as a database in my networks. So I created a simple Python script that does almost the same as the shell script that you've seen on the previous slide, but against a PostgreSQL Kia lease database. And you can find that on the link provided here. It's also open source under a BSD license. Currently, it only supports PostgreSQL, but once I find time, I will implement also support for MySQL in there. For process monitoring, you can use Kia control. The command Kia control gives you information about the Kia processes, which processes are currently running and are active, which processes are inactive. That is a quick monitoring that you can do from the command line, a more manual kind of monitoring. If you want to automate that, I would recommend doing that with systemd on Linux. The Kia packages come with systemd unit files, and you can start and stop and control the Kia services from there. And also systemd exposes an API, which is the dbus API, and it is possible to create a monitoring system by reading the dbus API information and responding to events that are going through the dbus API. And here are two examples on how to do that. The first web page describes how to build a monitoring system using systemd and chronograph. And the second one is a Prometheus exporter for systemd services. So with that, you can have the state of your Kia services, for example, visualized in Grafana on a dashboard. Also, every Kia process exposes its own REST and JSON API, and you can use that API also to monitor the health and function of the Kia services. And that is then independent from Stork. So you can basically do the same stuff that Stork is doing, but in your own flavor. People have done that already. There is the Kia exporter for Prometheus that is like a bridge component that reads from the Kia API and then pushes the data into the Prometheus system. From there, it can be visualized with Grafana. Sometimes it is required to do DHCP function monitoring in order to find out, does my DHCP system works? Do I get leases back if I send a DHCP request into my network? And there are a couple of tools available to do this function monitoring. One is DHCP ping. That DHCP ping tool sends DHCP request or DHCP inform messages and then listens on the response packages coming from the DHCP server. It also will try to obtain a lease, and if it is successful obtaining the lease, it will release the lease immediately to prevent a pool to be running full, because this is just a monitoring function. It should not take IP addresses and keep them. There's an original homepage for DHCP ping, but the code on that page has not been updated for a long time, and someone has taken the source code and made some changes and updated that for more modern systems, and you can find this updated source on GitHub. And the updated version of DHCP ping is what I've used for the examples here. So this is how you can use DHCP ping, -v for verbose, -s for server. You can either send directly to one server, or you can broadcast DHCP v4 into the network. -h is the hardware MAC address that we are simulating here. And -c is the IP address that we request as a hint. And DHCP ping will print out the fields in the DHCP request package. And then it will print out whether it will get an answer or whether it will see no answer from a DHCP server. Here we got an answer from the DHCP server in 192.0.2.1. And we see that was a DHCP not acknowledged message because of the IP address that I've requested is not available. And then we see the DHCP release that DHCP ping has been sent in order to make sure that the requested IP address will not be blocked for the monitoring tool. DHCP test is another DHCP test tool that works very similar to DHCP ping. It's a little bit more modern. It's written in the D programming language. That makes it a little bit harder to compile because a lot of people have knowledge about C and maybe Go, but it's not rocket science. You have to install the D compiler, and then you can compile this test tool as well. And then you can run it with DHCP test ---- query, and it sends then a DHCP query out into the network and prints out the responses. When we talk about monitoring of DHCP services, it's important to mention that it's good practice to monitor for pool depletion. In the case of Kia, it's important because the performance will suffer if there's a very high pool utilization, because Kia needs to check every IP address in order to see if it is available. We have talked about that in the last webinars when we talked about how leases are being assigned and about reservations being in pool or out of the pool. The more leases are in the pools, the higher the pool utilization is, the more work Kia needs to do to find the free IP addresses. And if a DHCP pool runs 100% full, then there's a risk that a DHCP client will not get an IP address and cannot join the network, basically cannot work. How can we deal with the pool depletions? We should check for the reasons. It might be that the lease time is just too high for the number of DHCP clients that we have in the network. One countermeasure could be to lower the lease time so that there's a higher churn rate of leases. Leases are being released much more frequently, and new clients can pick up then these leases. It might also be that machines are not releasing the lease on shutdown. So especially if you have high lease times, if people just join the network once and then they might not come back for a later time, but they are still owning the lease and blocking other clients from joining the network there. And sometimes it's malicious or just buggy DHCP client software that doesn't play according to the standards, and that might eat up DHCP leases without ever releasing them. What can we do? If you have Microsoft clients, there is a special DHCP option, which is a Microsoft own option that you can configure on a DHCP server that instructs the clients to release their lease on shutdown. Because in default, at least some versions of Windows don't do that. This is especially useful in public places like public guest wireless networks, where clients often join once and never come back. Or, and that would be my recommendation, consider switching to IPv6. Because in IPv6, you can make the pool as large as the current internet, and it will never, ever run full. So one problem less if you have IPv6. So that was about monitoring. And now we have a peek on the logging options that we have with the Kia servers. Kia has very flexible logging, and there's an extra chapter in the Kia administration's reference manual about logging, and it is linked here. The log output can be written to one or more target. It can be written to syslog, it can be written to one or more files, or it can be written to standard out or standard error. Now you can have, for every log target, you can have these, you can log to one of these targets, or you can log concurrently to multiple targets. So it's possible to log the same log messages to the syslog, log them also to a file, and also to standard out or standard error. Here we have an example of a log configuration, and this log configuration is for the DHCP v4 service. And because it is a logger name that sits on the very top hierarchy of the Kia DHCP v4 service, it logs everything about the DHCP v4 service, and it logs that into two different targets. The top target is logging to standard out, and it defines a special pattern that is also in the default configuration of Kia. And this is if you want to have the log information also in the systemd journal. And the second logger, where the output is into var log Kia DHCP 4.log, that logs into a log file. And there we can specify the maximum size in bytes of that file and the number of generations of that log file. And Kia will take care of log rotation itself. So there's not, it's not required to have an external log rotation system. Kia can just happily do that on its own. So about the Kia loggers, Kia log messages are sent from different logging modules, and these logging modules have different logger names. And you need to specify the logger names when you create your logging configuration. These logging modules, they have a hierarchy. There's always a root logger that is named after the service process. So there's the Kia DHCP v4, there's a Kia DHCP 6 service, there's the Kia DDNS logging service. And then below the root logger, there can be one or more other logging modules that send specific logging information, and you can then have specific log configuration for this. For example, you can have information on everything regarding the evaluation of client classifications. You can log that specifically to a different log file. And that makes it easy then to find the correct information in the log file. There's a long list of all the loggers that are currently supported in the Kia documentation, and you will find that on the link provided here on this slide. Here's an example of Kia log output. And there you see in the first columns the date and timestamp and the severity of the log message, info or warning. And then I've marked that here with the green and red rectangles. The green one is the root logger's name. And then separated with the dot, it's the logging module. So here, all log messages are for the DHCP4 service, but it is for different modules. So there is one message from the hooks module, one from the DHCP, or 3 messages from the DHCP4 module, one from DHCP service, and 4 command module messages. And it would be possible to create logging configuration that sends these different log messages from the different modules to different targets, different log files, different syslog configuration, and so on. So if you put the name syslog in the output parameter, the log messages will be sent to syslog, and you can specify a different service name that is then be used in the syslog messages. When you write syslog : and then the name of the service name that you want to use. We have one example here where the output is sent to syslog : DHCP4. And then DHCP4 will be the service name instead of Kia DHCP4. So when logging to a file, we specify the file name where we want to log to, and we can configure rollover with max size and max version numbers. There is a pattern option in the log configuration, which we can use to specify what data exactly we want to have in the log messages. The pattern comes from the log4C+ system, which is an open source library being used by Kia, and you can find the documentation on the pattern format on the log4C+ website that is being linked here. So here's one example. We have an output statement and then a pattern statement. And the pattern statement takes a string, and the string has special format entries there. The format entries are prefixed with the %, and this specific pattern line will create the output that we see on the bottom. So you can change the date formatting in the messages. You can switch around the message itself and the module names, and quite a number of other specifiers are possible as well. If you run a Kia service under control of systemd on a Linux system, if you configure the logging to write to standard out, that information, that logging information, will be stored in the systemd journal. And especially for new system administrators, systemd journal has the benefit that it's more easier to query for specific information in the journal than it is to filter through a large log file, especially if you don't know org or Perl. So here's an example of querying the journal for Kia with journal control. First, with the --sins we can specify a start time or a time period from where we want to see the log messages. -u is the unit name. Kia DHCP4 is then the DHCP4 service, and --grab allows us to grab for any text and filter for any text that appears in the log messages. So here I wanted to see all the DHCP4 lease advertisements, which gives me all the hardware addresses and the dates and times when advertised messages have been sent out. In the Kia version 1.9, which is currently in development, it is possible to restrict access to the Kia API commands to only authorized users. And that is being done with the HTTP basic authentication scheme, because the REST API is a web service, so it uses HTTP. So it's just a logical choice to use HTTP basic authentication for that. And in that new version of Kia, it is possible to log the authorization information into its own logger. And we see that here, and I scroll a little bit to the right side. Here we see that there was an HTTP client request authorized for the admin user. And then the following command that is just below that is the command that has been authorized. In this example, it was the list commands command. Because the Kia control agent at the moment always works on the API requests in order, we can rely on the fact that the log messages are always in this order. We first see the message that tells us who has authenticated, and then the next line tells us which command has been authenticated. Sometimes we need to enable debug logging, and the quick option there is to start the whole service in debug mode. Here we have the example of the DHCP4 service, starting that in debug mode. First, I'm stopping Kia DHCP4 from systemd, and then on the command line as root, I start Kia DHCP4 with the -d option, and D stands for debug, and that starts the Kia service in debug mode and will print the debug output directly to the terminal. However, on a busy server, this will log just everything for the whole DHCP4 service, meaning all the modules that are available there. And that might be too much to really figure out what's going on. So in that case, it's better to enable the debug logging just on a specific debug logging module, like it is done here. So in this logging configuration, the default log output is of severity warning with debug level 0. And only the module flex ID hooks, that is being logged to a specific log file. And there we use severity debug with the debug level of 55. Last chapter for today is about performance testing. The Kia development team constantly does performance tests on every new Kia version. And they've written their own DHCP performance measurement tool called perf DHCP. And that is open source as well, and it is available from ISC. And you can use that to also do performance testing on your Kia instance or on any other DHCP server installation if you want to do that, because it's just using the standard DHCP protocol. The Kia Administration's Reference Manual has a chapter on perf DHCP that explains all the options that are available and how to use that. And an older documentation from from some years ago that has some usage examples, like real-world command lines that show how to use perf DHCP to test a DHCP server. And that concludes session number 5 of our Kia webinar services. The next and last webinar will be on 2nd of December, and there we will talk about migrating to Kia from ISC DHCP. Most users of DHCP servers today still run ISC DHCP, but Kia is so much better, so much nicer, at least in my point of view, from my point of view. So I will tell you about how you can move from ISC DHCP to Kia with the least amount of hassle. So here we have some resources that you can use on Stork. There's a good video from Vicky and Tomek about the Stork management dashboard that has more demos than I had in this webinar presentation. There's the Stork documentation and Stork's project page, and there's a mailing list if you have ideas, comments on Stork, or some questions. You can subscribe to the mailing list and find help there. And now, Vicky, do we have questions? Oh, we have a poll.
Yeah, I'm just going to leave the poll up for a minute. I have 2 polls. They're pretty short. We do have a few questions. We have some questions that we've already sort of answered in writing as you were presenting, but I think we'll just review those. Tomek may have some more comments on some of them, and we have at least 1 or 2 questions that are still unanswered. So the first question from Ben, does Stork update the polling services on a server automatically? For example, if you have a server running only DHCP v4 and later you add DHCP v6 on the same server, does Stork update with a new service, or do you need to remove and re-add the server in Stork? So I actually answered in writing to Ben that the Stork agent will detect whatever services are running on the machine that it's on, and if the server is already being monitored by Stork, it will show up automatically. If anybody wants to correct me or add to that, you may chime in. We had one question, which is almost a perennial question. No matter what database we support, somebody wants another one. Kevin said, will there be support for MySQL or MariaDB? And I assume he means as an alternative to Postgres. And I said that, you know, my own feeling as a product manager is that we're focused on extending the functionality of Stork and not adding more platforms. So it's not a priority, and I don't see us doing this anytime soon, but Tomek, if you want to chime in, please feel free.
Okay, so basically the answer is no, unless there are some very good reasons. This is one of the mistakes that we did with Kia, is that we added too many databases too early. And suddenly people started asking for other databases like SQLite, MongoDB, and other things. The problem is that if you have more than one database, it becomes much difficult to implement new features and also test it. So, and Stork is a relatively young project, and we have a very small team working on it. So we basically cannot afford getting this kind of testing commitment. So for the time being, Stork is and will remain Postgres only.
Yeah, it's kind of a, do you want to go deep or go wide kind of a thing? You know, we could have a lot of platforms and not have very much functionality. But I do understand that the question is really because we do support multiple databases on Kia. There was another question from Chris. Can Stork be configured to use Active Directory? This was when Carson was demoing setting up users. So he was looking for, you know, some kind of different authorization methods or channels. And the answer is that right now the user details are stored in the Postgres database. So no, we don't have integration with any other authorization domains. It's something that I expect that we will want to add at some point. But at the moment, the early users that we have of Stork seem to really only have a few admins. And, this is something that seems like it's much more important as you scale up, and it's kind of a it seems not essential at the moment. We always, welcome input. Let's see. We had a bunch of comments in the chat that everyone can see. Oh, here's an unanswered question from Chris asking, do we have any suggestions for steps in the debug level range? So what do we recommend for typical debug setting? It's a little bit of an unanswerable question. Obviously, it depends if you have a problem we're looking at. Timek, do you have any comments about that?
I have some comments, but they are probably will not answer the question. I mean, like, this is probably one of the worst documented parts of Kia. So the logging levels are not clearly stated. So we probably could have done this slightly differently, and it's not really consistent. So depending on who was working on a specific part of Kia code, the logging levels are somewhat different. So yes, it's complicated. So if I'm debugging something, I always enable debug level 99, which gets absolutely everything, and this can kill your server. But it's useful to then grab the data. So yeah. Other than that, I get the point that we could have made this cleaner.
Yeah, so Chris is asking if there's any magic levels, like, use level 10 for this or use level,
Sadly, no. There should be, but there isn't.
Okay, so that's a long-term feature request. I'm just scanning to see if there are any other questions. It looks like we have another question in the Q&A. Okay, so once again on the databases, this is from Kevin, will Kia support Postgres for the config database, the config backend?
Yes, that's the general plan in 2021. We don't have any specific dates. Right now, we are getting lots of requests from customers, and this is slightly unpredictable. But yes, we definitely want to implement Postgres support for config backend. The idea was to implement it for one database, then get some operational experience with it, and then do the second implementation.
Okay. All right. Let's see. Can I share? I just put up one other poll. I don't know if I can share the results until.
Should I stop sharing? I do that?
No. That's not it. I think let's just let people vote on the second poll, and then I should have the option to share the results from both of them.
Good.
So one thing that we considered in developing Stork was whether or not people would prefer to use a management application that managed a lot of other applications, manage their network equipment, that sort of thing for fault management, or if they would prefer a dedicated application. Among some of the first things that people wanted to, were asking us, how do you manage this, were pool utilization and the high availability status. And the problem is that neither of those was really very straightforward to manage in a traditional fault management application, because you want to look at configuration, the current configuration status, in addition to the, the active state of the server. So that was really the logic behind this. Okay, so since we've got at least 60% of the people voting, let me share the results. So here's for the first poll. What's the primary management concern? What's your primary management concern with managing Kia? And I realize that most people probably looked at this and said, well, I want to check all of these. But anyhow, the poll tool in Zoom is not that sophisticated. So managing overall system utilization and performance was the top vote, but after that was HA. So basically everything, not too surprisingly. Okay, let's just check the next one. And here again, we've got people on both sides of the fence wanting to integrate Kia with a general purpose fault management system is preferred to having a dedicated management application. And my expectation is a lot of people will, in the end, have both, but thought I would ask. So I think that's it, and we are out of time. I'd like to thank you, Carson, for another informative webinar. And we will, as always, be posting the slides and the recording on the website. Those should be up by Friday. And then we'll see you in 2 weeks. Is it 2 weeks?
Yes, 2 weeks this time. 2nd of December.
Okay, great. Well, thank you very much.
Thank you, Vicky. Thank you, everyone. See you next time. Bye.